Oh yeah. How we doing, everybody? Welcome. All right. What's up, Rob? Welcome. And we got Richard Hill here. What's up? Welcome. Hello. I like this song. I was kind of rocking out to it a little before we officially started. And Anhoy, welcome. And Ali is here at 2 a.m. What's up? And Jeff S is here as well. Welcome. Richard, Rob, Anhoy, Ali, Jeff S. Welcome, one and all. It's going to be a little bit of a lighter night tonight, I think. There are some technical conferences going on throughout the world. And I know there's a lot of people who usually tune into my stuff that are going to be at least one of those conferences. So I'm very, very thankful, very honored to have those of you here who are here with me tonight. Thank you so much for joining me. I got to tell you already, I am very much liking this time slot. What's up, Rich K? How you doing? Welcome. What up, Tar and Jot? Welcome. And Randall Thompson is here too. Welcome. All right, we got the whole crew tuning in. Brian Jackson is here, trying this for the first time. All right, welcome, Brian. Thanks for joining us. And welcome, everyone. Yes, tonight is Model Monday Live, the night where you can tune in live and challenge the rest of the chat. Now, there's been one gentleman, Airwick, who has been absolutely crushing this contest for the past, I think 6 weeks. He's been on a streak. His streak got broken last week, finally, but I haven't seen Airwick in the chat yet, so maybe that should be motivation for us to get started sooner rather than later, just so that we don't have Airwick show up and just blow everybody out. Reed Grubbs is here. What's up, Reed? Welcome. Thanks for joining us. And Rob N says, it is Tuesday, 11 a.m. for me. Wow. Okay. Coming to us from the future. Well, welcome. Thanks for joining us. This is a perfect time slot for you then, Tuesday, 11 a.m. So welcome and thanks for joining us tonight. And let's get into it here so we can jump right into our speed modeling challenges. Rob N in Australia. Rich K, I think, is in Australia as well. So you guys can maybe hook up later and hang out and talk about CAD and talk about the speed modeling challenges from Model Monday Live. All right, let's get into it here. Rich K, let me know if I'm wrong there. If I am, I apologize, but I think that's right. All right, so tonight we are going to talk about some Model Monday, some modeling challenges, Model Monday Live. 1 p.m., Rich K says, in New Zealand. Thank you very much for confirming. I apologize for getting that wrong. New Zealand versus Australia. What we're going to talk about tonight are speed modeling challenges. Mainly tonight is going to be me challenging you guys to do some speed modeling and then me doing some live solves that I'm going to then cut up and repost on the channel. I've been trying to catch up with some of those live solves, which I'll talk to you about in just a little bit. Robert G is in the chat, says, I love the soft TTT shirt. Yeah, if you guys are out there and want to pick up the softest shirt in the CAD game, be sure to check out the TooTallToby shirts. They are available at TooTallToby.com/merch. And they are indeed the softest shirts in the CAD game. Make a great gift. Make a great shirt to wear over and over again. I want to let you guys know that even though there are some technical conferences this month, I'm not going to necessarily be at all of them, but I am going to be doing some additional live streams, some additional tips and tricks. One of the things I'm going to do is actually tomorrow, I'm going to do a tips and tricks on Valentine's Day. So I know that it was a little bit clickbaity. I said tonight we're going to talk about love and Valentine's Day. I mean, the one thing I want to remind you all about is that tomorrow is Valentine's Day. So be sure to take care of your special person. Make sure that they know that you love them. Make sure that you get them that special gift, or the best gift of all, of course, is time. So maybe just schedule some time, get a sitter for the kids, spend some time with that special person. And if you don't have a special person, that's okay. Maybe just call up one of your friends and hang out with them and just say, hey, we just, we can hang out together here on Valentine's Day. But just don't forget. That's the biggest thing. Don't forget. Very important. You don't forget altogether, because I can get you into a lot of trouble. And I know that as time goes on, it's easy to Sometimes forget these things. All Day in the chat. What's up, All Day? How you doing? I know All Day has one of these TooTallToby shirts. I've seen him rocking them on the social media. So if you're out there and you haven't picked one up yet, be sure to check out. Rich K says, I can confirm the shirts are soft. Thank you. Thank you. Thank you. So that's tomorrow, Valentine's Day. I'm going to be doing a really cool tips and tricks where I talk about how to use photos in SolidWorks, how to work with splines, how to work with display states. A lot of people don't understand how display states work at all in SolidWorks. And so I'm going to explain that tomorrow. And then I'm also going to talk about how to use the configuration name to drive the text on a model. So that's a really fun presentation. I've given that before. A couple of years ago, I gave that presentation. Going to make a modified, updated version of it for tomorrow. Then on the 20th, I'm skipping Model Monday Live. The 27th, we're going Model Monday Live again. This same time slot, 7 p.m., because I am very much enjoying this time slot more than the 9 p.m. East Coast USA. And then Tuesday, February 28th, the next day, we're going to do another tips and tricks. This is going to be the big Toby's Tips and Tricks 2023 presentation I've been working on for a little while now. All day, you got to see a little preview of this presentation live when we were down in Texas together. But this is another exciting presentation I've been working on for a little while now. And I love the way it's all come together, and I'm ready to share it with the world. And February is the month to share some of these kinds of presentations. So Toby's Sketching Tips and Tricks 2023. Tune in live Tuesday, February 28th, and we will share those amazing tips and tricks. And so today we're going to do some speed modeling challenges. We're going to do a live solve, another live solve, maybe even a third live solve. And we're going to talk to, of course, the best chat ever. And we will see what comes about. I want to remind all of you out there that regardless of what CAD system you are using, it's important to have solid hardware to run that CAD system. One of the worst things that can happen is you can buy yourself a brand new computer, load up your first assembly, and run into error messages like your system is running critically low on memory. You don't want that to happen, and one way that you can prevent that from happening is working with the outstanding team over at SolidBox, mysolidbox.com, because what they'll do is they'll help you spec out an engineering grade computer with impressive specifications to begin with. But then before they ship you that computer, they will go through and make tweaks to Windows and make tweaks to the BIOS that are specifically for professional CAD and CAM engineering. And the reason the team at SolidBox is able to do this is because they've assembled a team of professional CAD and CAM engineers who really understand how to run the benchmarking, analyze the benchmarking, troubleshoot the benchmarking, and make sure that that computer is ready to go. Listen, most of the customers that SolidBox gets become customers for life. And I can't think of a stronger testimony than that. So be sure to check out mysolidbox.com anytime you're in the market for some new hardware. These are definitely a wonderful outfit to partner with, and they will set you up, set up your team. And like I said, most of their customers just become customers for life because it takes all of that IT overhead out of the picture. You don't have to, get a new computer and then go to IT and have them make these tweaks or, adjust things. You don't have to worry about any of that. It's just as soon as you get the computer, it's ready to go, and SolidBox will take care of you. mysolidbox.com, anytime you need a professional level CAD or CAM workstation. So with that, let's get into it. I know there's a couple of people in here who are coming in for the first time. I know that, who was it that said that earlier? Brian Jackson is here, said that he's trying this out for the first time. So let's go over some basic rules for anybody who's here for the first time. I'm going to show you a 2D print. You're going to turn that into a 3D model. You're going to calculate the mass of that model, and you're going to enter that mass directly into the YouTube chat. The first person to enter the correct mass into the YouTube chat will win, but I'm not going to tell you the answer right away. I'll let everybody have a chance so everybody can, compete against one another. If you submit your answer and then you realize that it's wrong, that's okay. You can adjust and submit a second answer, a third answer, as many answers as you want during Model Monday Live. You can use any CAD package, but you need to be able to input the density. And I'll show you those material densities in just a moment. And of course, output the mass. Make sure you use the specified precision, which is on the print. And the first correct answer in the chat will be declared the winner. Listen, tonight, all the answers are in whole numbers. So you don't have to worry too much about the precision, that middle item there. But sometimes you do. Sometimes I ask for it in 2 or 3 place precision, and that becomes more important. These are the units that we use, so I'm just going to leave this up on the screen for a moment. Please take a screen capture of this so that you understand what units you are going to be working with. And really, I think what's more important than the units is the material density. So take a look at the bottom there. You know, if you're using a different CAD system than what I used when I created these things, then your material density might be a little off. You want to make sure that you're using the correct material density. Otherwise, obviously, your answer will also be incorrect. And the advanced rules are, this is meant to be fun and good-spirited. Occasionally, I will make a mistake. I remember a couple of weeks ago, I left off a diameter on the print. I try not to do that, but occasionally it does happen, and when it does, we'll just kind of adjust on the fly. And the Ivan exploit is permitted, and the Ivan exploit is, it's discouraged to a degree, but, you know, sometimes I make sheet metal parts and I can't really get around it, so the Ivan exploit is permitted. Permitted, but discouraged. Let's put it that way. All right, so what's going to happen now is I'm going to show you guys this 2D print full screen, and you are going to take a screen capture of this, you know, Windows snipping tool, whatever. Once you take the screen capture, you can move that over onto your second monitor and begin modeling in CAD. If you don't have a second monitor, well, once I show the 2D print, you could just pause the video, like if you're watching from your phone or something like that. You can just pause the video and keep working from your phone, or you know, or you can take a screen capture and kind of maximize the screen capture. It's really best if you have a second monitor, but if you only have one monitor, you can maybe tile your windows. But after I show the print for a couple of minutes, I'm going to move on and talk about some other stuff. So be sure to take a screen capture. All right, this challenge is going to go live in 3, 2, 1, go. What is the mass of this part in XXXX grams with a tolerance of plus or minus 1 gram? The material here is plain carbon steel, which has a density of 7,800 kilograms per cubic meter. The units are in millimeters. This is actually a model very similar to a model we did during the tournament last year, the Odd Wrench. This is Odd Wrench 2. It's a little bit of a modified version of the Odd Wrench, but pretty similar for the most part. You can see here that the Odd Wrench has a view from the front with an arc and then a straight section and then another arc. So, you know, make sure that that geometry doesn't get merged together. A little bit of a hint there, I guess, as to how you could create that feature. I mean, look, you guys probably realize this. You can make that middle feature there with a sweep, right? You've got a cross section. You can create a path. You could make that middle section with a sweep. But just make sure you don't use the option for merge tangent swept faces. Otherwise, you're going to end up with a spline there. And that's not what you want. You want an arc with a radius of 85 at the bottom. You want a straight section going at 35 degrees, and then you want another arc. So make sure you don't use that option for merge tangent faces. Usually what your software will do is convert that line arc line into a spline, and then you're gonna be slightly off. And when we're looking at 4 digits with a plus minus tolerance of 1 gram, you know, so basically 0.1%, that's pretty tight. I don't think you want to make any leniencies. Being tough on this one. So take a screen capture of this, do a window, capture the screen, all the dimensions you need are there, and get that onto your second screen so that you can keep working after I move on with the presentation. This is a fun model to build. Lots of good stuff that you can learn from a model like this, so I will look forward to doing a solved episode on this one as well, sometime in the future. All right, we'll leave this up there for about 5 seconds, and then we are going to move on with our presentation tonight. It's a good song. Good song to get started with modeling, for sure. All righty, let's get back to it here. So a question came in from Rob. What is the Ivan exploit? So the Ivan exploit is basically, like on this print here, you can see that this square, my mouse is pointing to it. Let me zoom in on it here. You can see that this square here is on a face on top, and then there's a face on the bottom here. So these two faces that I'm pointing to, the face on the top and the face on the bottom, are parallel to one another. Well, in that situation where those two faces, the start face and the end face, are parallel to one another, the location of that square hole becomes irrelevant relative to the mass of the component, the final mass of the component, meaning that square could be anywhere on that face. Now, with this model, there's not really that much value in knowing that because that square is, is centered on that lower face. Although now that I look at it, I realize I didn't actually call that out really, that it's centered. I should have added a 14 dimension and a 14 dimension here. So there you go. There's an example of Toby missing a dimension. That does happen sometimes. I do miss a dimension from time to time. But that square is centered on there. Definitely... Whoopsie! Very first one here for some of our runners. For Brian, sorry Brian, but that should be centered on that lower face. But hey, due to the Ivan exploit, it doesn't even matter if it is centered. So there you go. It all works out in the end. But that's the idea of the Ivan exploit. Sometimes that can be very valuable as far as time goes. But it's just something that I can't really. I don't get a chance to see your models, so I can't really prevent that from happening. Now, there are things that I do when I'm creating these models, like I'll make the bottom face slightly angled, and that way the location of the hole does matter. Those are like my efforts to thwart the Ivan exploit. So let's just talk for a minute about the 2023 leaderboard. This is a really cool thing that we started doing here in February. There is a leaderboard. If you go to TooTallToby.com/leaderboard, where you can see that I've posted 3 models, 3 drawings, like what we're looking at here. And I challenge the audience to go through and create those three models. And the audience attempts to do so in the shortest amount of time possible. Here's what the leaderboard looks like live. So this is the live leaderboard here. So you can click on this little picture of me and you can get the rules explained to you how to do it. You can click here if you want to see what the 3 drawings look like. And then what's really cool is that when you go down in here, you can actually click on the video and it takes you to the video of the person running this thing. So looks like that one was... That Ali ended up having a problem with his first run there. He missed a dimension, and he actually still got the correct mass, but I noticed that he missed the dimension. But the run here, let's take a look at this run here. So this run, you can see this is by Airwick. So Airwick was using Onshape to perform this run, and you can see that when you go through and you do the run, there's a clock over here on the right. And you begin creating these models using the dimensions that I specified in the prints that are back on the previous page in the rules. And your goal here is to create all 3 of these models as quickly as possible. And the cool thing is you can run them as many times as you want. You can practice, and then hit record and actually try to make your speed run. And as long as the geometry is correct, it's a valid speed run. I'll validate it and I'll add your video to the leaderboard. So you can see here, I fast forwarded to the end here. You can see that Airwick was coming down the final steps of this thing, adding in this counter bore, waking up the center point and putting in the correct geometry there for the center point, and then doing a mirror command and mirroring that body, and then he was able to calculate the correct mass, and that correct mass allowed him to stop the clock and come up with a total time of 4 minutes and 51 seconds. So, and wow, look at this one. Frank's in here. I didn't even see that Frank had a video yet. I'm going to have to save this for a little bit later. Wait, is Frank on the leaderboard? Maybe he is on there. Oh, yeah, he's on there. Right, yeah, cool. So Frank's on there too. So yeah, so it's all automated. The only thing I have to do at the end is just watch your video, confirm that you did everything right, and then basically approve your video. I told Ali earlier today that I couldn't qualify his video. I couldn't verify his video because he missed that dimension. And he said, okay, I'll just do it faster. I'll just do 3 models in 3 minutes and 44 seconds. So if you want to watch somebody just totally screaming through that speed run, Ali also did one last month where he did 3 models in 3 minutes. Very impressive. But, it can take up to 50 people. We can take up to 50 people on this leaderboard. So even if you don't get, shorter than 3 minutes, that's fine. So you can still give it a try. And it's just cool to be on here. And at the end of the month, I'm going to do a raffle where I'm going to give away a t-shirt to someone on the leaderboard, in any position. It doesn't have to be in the top 10 or anything like that. So the leaderboard has been a lot of fun so far. I've really been enjoying watching people run it and using different CAD systems, and getting to see how the different CAD systems work, I think is really cool and a big part of what we do here on this channel. On that same note, 11/11/23, That's the date for our tournament, our CAD vs. CAD tournament, our finals. So November 11th, we're going to have the semifinals and the finals the same day, but we're going to have 32 people running that tournament, and that tournament's going to begin probably in August, maybe even in July. We're still working out the final schedule for that thing, but we're going to have all the dates posted very soon, and it's going to be every Saturday, once again, at 10 a.m. East Coast USA. That seems to work out the best for the global audience. We had, I think, 13 countries last year that submitted for this thing. We had 6 different CAD systems, so it was really cool. And in that battle, it's 1 versus 1. Are you faster than your opponent? And who makes it through to the end. Very, very fun format, and looking forward to tournament season. As soon as it was over last year, I was like, I got to get back into tournament season. So maybe we need to start having 2 tournament seasons every year. I don't know. Maybe that'll be 2024. All right, guys, that's enough of an intro. Let's do a live solve, or maybe even 2 live solves here. I'm going to do a live solve of this. It's a C-clamp base, and then I'm going to do one of the angle bracket. So let's get into it here. These live solves are sponsored by SOLIDBOX. Once again, SOLIDBOX very much helping us out with the channel this season. So let's do a live solve of this part here, sponsored by SOLIDBOX. If you ever need computers for CAD, talk to the guys over at SOLIDBOX. They'll definitely take care of you. But when it comes to creating a model like this, anytime you receive a model, a drawing, whether it's a hand sketch or whether it's a professional drawing, or even maybe something for school if you're a student, and this is advice that applies across every CAD system. What you want to do at first is you want to look at that model and you want to come up with a basic game plan. And what I usually do is I kind of unbuild the model in reverse. So I think to myself, you know, what's going to be the very last feature? What's going to be the first feature? And these types of things come with practice. You can really learn how to do these types of things. But I think that for me, what I would do is I would look at this model and I would kind of ignore this section over here that's sticking out on the end, and I would just kind of focus on this shape with the rounds, and then I would take that one step further and I would ignore these rounds up top, and I would just imagine them as being sharp. And so what that then leaves me with is the idea of drawing this shape here as the start of my model. So this allows me to figure out what my starting plane is going to be. It's going to be the front plane of the model, and also what my starting sketch is going to look like. It's going to look like this shape here, this kind of U shape as my starting sketch. And then once I have that first shape sketched with the sharps, then I can come in here and I can add the fillet. I could either do that as a full round fillet, or I could do it as 2 half round fillets, you know, at half of this wall thickness. And then once I have that shape, you know, there and also here, then what I can do is I can easily create this additional extrusion here for this circle. And then I can finish up with either a cut extrude or a hole wizard hole, creating this countersink here that's running through the entire model. So that's going to be my game plan going into this thing, and it's very important, regardless of what CAD system you're using, that that's where you begin. You begin by just thinking through, how am I going to build this thing? What is my game plan? So now that I've got that game plan in mind, let me move this over to my second monitor, and we will attempt to create this model here in SolidWorks. So here I am in SolidWorks. I'm going to go. Let me just make this a little bit smaller here. Make this a little easier for everybody to see. There we go. All right. So we're going to click new, and once you click new, we're going to choose a template. Now, your new screen might look like this, or it might even look like this. What I always advise everybody to do is click on the advanced button when you get to this screen for your templates, and at least choose a template from here. And we'll talk more about templates sometime in the future, but what you want to do is you want to get in the habit of making sure that you're working with the correct units, and those units are going to be found here under options, and then under document properties. So you go options, document properties. Really, everything that's on this tab here, document properties, is stored in your template. So if you find that over and over again, you have to go in and change your units, like I want to be working in millimeters, but every time I'm working in inches and I have to keep changing it, well, you need to change that option and then do File, Save As Template and make a new template. But again, we'll talk about that more in the future. For now, let's just make sure that we're working with the correct units from the drawing, which is millimeters. And then we're going to go front plane, begin a sketch, orient our view, and we're going to begin creating that shape that we described a moment ago. And so we could create that shape maybe by starting up top here and coming down with a line and then doing a single click, and then you move away from that line and you come back and you touch that line, and that takes you into an arc command. Now, I know that I'm using SolidWorks here, but there are some other CAD systems that have a similar functionality, and you definitely want to learn if your software has something like this, a line arc line functionality or auto transition to tangent arc functionality. This can really make your life a lot easier and make your model creation a lot faster if your software does have this and if you learn how to use it. So the line arc line functionality, there we go. Now you'll notice that I decided to drop the origin here at this lower corner. In the case of this model, it doesn't really matter that much. I mean, the model is going to be centered, but it doesn't really matter exactly where I put the origin. There are a few different options as to how to create that, that model and where that origin should be. But frankly, in this model here, it's not really that important. So I'm going to go through and I'm going to add in my radii. Now, having your radii in the original sketch versus having them in created later as features is another kind of a debate that people will get into in the world of CAD. In this case, I'm just doing things very fundamentally, kind of getting you to follow fundamentals. But you may come to a point where you decide, like, this is way too many sketch relationships, this tangent, 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 tangent. I don't want all these extra sketch relationships. And so I'm just going to make my first sketch sharp, and then I'll add those fillets at the feature level, and that certainly is a valid strategy. Now, at this point, we're going to run into a little bit of an issue because we don't have a dimension for the height of this stuff here. We don't have a dimension that gives us a height. The only thing we really have is this 31 that's coming up to this location here. So maybe we want to do a little bit of math, like this thing is 16 wide, and it's a full round going across the top here. So we can figure that it's 31 plus 8 to give us that radius. And sometimes what I'll do in this situation is I'll actually sketch a center line. So I'll create a center line like this, and then I'll create my 31 down here, and then I'll create my dimension from the center line to that top line, and then put that in at 8. So that's certainly an option as well, and an option that I've used a lot, just to kind of make things a little bit more consistent with the drawing that I get from the customer. Now I'm going to type in my final dimensions here. Some of these dimensions I'm just kind of going through and not necessarily explaining. I think they're pretty straightforward, but if they're not, let me know in the chat, or of course you could let me know in the comments if you're watching the recording of this. So what we're hoping for is that our sketch becomes fully defined, meaning everything is black. And if it's ever not fully defined, the best trick that I can tell you about is just grab one of the endpoints, grab one of the blue endpoints or the endpoint of the blue entity, and just drag it around a little bit, and then kind of use your engineering intuition or geometric intuition, and you can say, hey, it looks like maybe that line and arc are not tangent to one another, and you can add in that relationship. So now we're going to go to the extrude command. Now for me, I'm going to use what's called the S key on my keyboard. It's one of my favorite features in SolidWorks. But we could also exit the sketch and then go up to features, our features toolbar up here. So after I exited the sketch, I was able to go to my features toolbar, and I was able to choose extrude. And now here I'm going to say I want to extrude that out to a depth of 16. And a lot of times what I do is I right mouse button in the background and I change the end condition to mid plane. I think that's a really handy shortcut, because as soon as I do that, I can then once again right mouse button. And when I right mouse button, you can see that finishes out that command. So that's kind of nice. It saves you some mouse travel. Now I'm going to press the S key again, and this is pretty much what the S key looks like when you're in feature mode. It looks a little different when you're in sketch mode, but the main thing you want to recognize is that the fillet command is right there on the S key menu. So I just press S on my keyboard, and I jump right into the fillet command. And I can say I want this to be a radius of 8, and I can say I want to pick this edge and this edge and this edge and this edge. And wow, that's setting me up pretty nicely. I'm getting, you know, pretty close to the end of this thing. Now, the next feature I'm going to create is just going to be a circle, but I'm going to sketch it here. Sketch the circle here and then extrude it out. And the reason I'm gonna plan that out ahead of time is because the drawing is giving me this dimension, the 23 dimension. You know, you might instinctively sketch the thing here, but then you have to do like 23 minus 14, and maybe I can't do that math in my head. And so instead I'm just gonna draw the circle over here on this end, and that way I can extrude it right out to the dimension that's on the drawing. That's another good tip, especially if you're just getting started in the world of CAD. Think about where you're creating your original sketches. Now, a lot of CAD programs will have tools that will automatically wake up the center point. That's what I'm doing here. And maybe even automatically hook to an existing endpoint or an existing edge. And that's what I'm doing over here. And so now I can jump into the extrude command. And I did that by pressing the S key. Of course, if you press the S key and you don't have the extrude command, you can do a right mouse button customize. And then you can go down to the section for features, and then you can drag and drop the extrude command right onto your S key menu. So that way, when you're in sketch mode and you press S, you know, you don't have to exit the sketch. You can just jump right into the extrude command. And that's going to go out to a depth of 32, nope, 23. And then I'm going to right mouse button in the background and say reverse direction. See, a lot of these commands that are over here, like the end condition of midplane or the reverse direction, you know, a lot of those commands are also right here in your right click menu. And I think a lot of times it's a shortcut just to get it right from there. So reverse direction, and then I will right click one more time. And then finally, I will finish up here with a hole wizard hole. These dimensions here that are called out in the hole call out, 5.5 millimeter through all hole. So this hole here is 5.5, 11.2 with a 90-degree angle on the C-bore. So that's this hole here, 11.2. And a lot of times the hole callouts, which are, you know, standardized per the machinist handbook, they will also be standardized in your CAD software, even if it's not what I'm using here, SolidWorks. Even if you're using a different CAD software, a lot of times you'll find that the whole tool, the magical hole tool that you have in your software, will you know, will have similar order of or call out information. Like this one here, you can see it's got the through hole, it's got the countersink diameter, and then it's got the angle of the countersink. So just like what we have on our print, 5.5, I'll just press tab, 11.2, I'll press tab, and now all I have to do is go to position, and I can drop that thing right on the center, and right mouse button, and boom, I'm done with that as well. And so to finish this off, what I'm going to do is I'm going to do a right mouse button over here on my material, and I'm going to get into my material library. And if I find that at my company I'm using the same materials over and over and over again, I'll make sure that I add those materials to my favorite materials, because that way I can just do a right mouse button over here and pick it right from this list of favorites. So in this case, this print is calling out 1060 aluminum alloy. So there we go. I've added that 1060 aluminum alloy. And then I'll finish up by going into my evaluation tool to find out what the total mass of this thing. So 91.99, I'm going to round that up to 92 grams. That's going to be my final answer. And we come over here to the 2D print here, and let's see if we got it correct. The live solve answer is yes. We did it. So if you enjoyed that, you know, be sure to let me know in the comments below, and be sure to like, and we will definitely be doing some more of these live solves or of these solves of these practice models. And that's a little break I had to do just to set myself up so I can cut that section of the live stream out and make it into a standalone video. Appreciate you guys being with me as I'm filming some of this, doing some of my homework here while we're doing the live stream. Let's do one more. We'll do the angle bracket. I'm going to go through this one a little quicker. That first one was more for beginners. This one I'll go through a little quicker. But this is gonna be the same process. So let's do a live solve here of the angle bracket. I want to, of course, thank SolidBox for sponsoring these live solves or these tutorials. Let's do a live solve here of the angle bracket, and the goal for this thing is to determine what is the mass of this part in XXX grams. The tolerance here is going to be plus or minus 1 gram. It's in plain carbon steel, MMGS. So once again, we have to decide what's going to be our starting plane, our starting profile, what's going to be kind of our plan for this thing. And when we're looking at a model like this, I think what's important is that we recognize that we've got centerline symmetry here going right up through the middle of the part. And so you could actually make the case to create this part by sketching this profile here on the front plane, extruding it mid-plane, and then adding the full round fillet here on this end of the part. And I think that's a pretty good plan. The other approach that you could take might be to draw this shape looking down from the top. So on the top plane, creating this shape here, and then extruding that shape to the wall thickness that's specified here of 7 millimeters. And I think that's a great plan as well. So either plan is good for our starting plane, our starting profile. You know, I like both of them. I think I'm going to use the latter, where I draw the top-down footprint. If you're ever not sure where to begin, a lot of times just picking the top-down footprint is a good solution. The other thing that we want to do with this model is we want to recognize where the origin should be. And I think that in a model like this, you know, it's either going to be right here at the center of these holes, or it's going to be back here at this location. Either one of those is a good location, but they both just really jump out at me just because there's a lot of dimensional information, particularly coming from this location here. So either one of those is a good selection for the location of our origin. Let's get into it here and see if we can't build this part. Again, I want to thank the crew over at SolidBox for sponsoring these live solves. If you ever need any kind of hardware, be sure to talk to the crew over at SolidBox, mysolidbox.com. So let's start a new part here, and once we start the new part, we want to make sure we're working with the correct units. Remember that down here in the status bar, there's a shortcut to pick your units. So if you ever find that your part is working with the incorrect units, you can use that little shortcut. That's a great time saver as well. Top plane, begin a sketch, orient the view. I'm going to press the S key and jump into the line command, and I'm going to create a line here that has a length of 38 using the auto dimension functionality. So if your software has auto dimension functionality, that can be another really good time saver. Most software does have something similar to that, and so it's definitely worth it to learn how to use that functionality. I'm going to pick this point here, which is the origin. I'm going to hold control. I'm going to pick this line, and I'm going to let go of control and make that midpoint. That gives me the tombstone centered on the origin. And then I'm going to go into Smart Dimension. I use the S key to launch Smart Dimension there. And then I'm holding Shift. So I'm doing a couple of things here with my left hand. I'm pressing the S key, starting the Smart Dimension, picking this line here. Then I'm holding Shift. And then I'm picking the arc. And that way I can pick right at the tangency point of the arc instead of having the dimension go to the center of the arc. I'm going to give that a value of 80 and then extrude. So S key extrude. And extrude that up to a height of 7. Enter, enter. Now I'm ready to create maybe the revolved shape. So I could maybe create this shape over here, this kind of revolved shape that's sticking up through the top. I could do that as 2 extrusions, or I could do it as a revolve. I'm going to do it as a revolve. So front plane, begin a sketch, orient the view, sketch a center line for my revolve. Jump into the line command, again using the S key. Bring a line over here, all the way out to that point. Come up to a height of, I'm not sure how much. Come up to a height of 7. Come over, come down here. This is going to go down to a height of 19. And then come all the way down to the bottom. And that height of 19 is going to lock right into this edge here. Finally, I need to specify a diameter of 26 for this location here. And then features revolve. And there we go. That gives us that kind of upper revolved region. I'm going to go to this face here, begin a sketch, orient my view, and I'm going to sketch a rectangle. This rectangle is going to have the auto dimensions at 30 by 10. And then I'm going to S key extrude that rectangle and pick this point here so that extrusion goes right up to that point. And then I'm going to right mouse button and finish that command. So these are some good little shortcuts, you know, for this example. Maybe I'm just giving you a little preview, but definitely worth looking into. Here I'm using S key, jumping into the fillet command and typing in the appropriate radii for these fillets. Gonna come over here to this edge of the part, begin a sketch, orient my view, and create a tombstone shape. So begin a line that comes up here like so. Come around here. This is gonna have a radius of 13/2. And then I will close off that tombstone shape. This is going to be vertically centered from the origin. So I pick the origin, hold control, pick this point and make them vertical. And then there's going to be one final dimension, hold shift here to get the top of that tombstone. And that's going to be at 17 millimeters. And we'll extrude cut that, right mouse button through all, right mouse button. And then we'll finish up top here with a 16 millimeter through hole. So select a face, begin a sketch, orient the view, S key. We're going to go here to this diameter of 16, S key, extrude cut, right mouse button through all, right mouse button. And that time I missed the right mouse button on the end, so I just went into the menu and picked OK. So now for our material, this is going to be plain carbon steel, which is right there in my favorites. It's nice when you have those materials right in your favorites. And then finally, we're going to go to our evaluate mass properties, and we're going to come up with a mass of 299.5, which actually doesn't sound right. Ali came up with 356 grams for this bracket. Oh, I missed a fillet. There we go. Missed a fillet. So here we go. Fillet, 3 millimeters. Had to look at my print again. Should have looked a little closer there. All right. Mass properties. Either way, it only added 1 gram. 300. I know that it was in the 300 range. All right, let's see who's right. I'll put in mine here. 300G. Let's see what happens here. Live solve answer is, oh yeah, 300. So I didn't even need that fillet because I was at 299.5 anyway. So having that fillet on there, you know, sometimes, like I said in the beginning, sometimes I make mistakes. All right, let's keep going. But on that note, I want to say thank you again so much. I hope you guys enjoyed that tutorial, and be sure to like, be sure to subscribe, and you know, be sure to tune in for more of these live solve tutorials. These practice models are great practice, but I think being able to see how an expert goes through and solves it is also very useful. And so with that, if you guys ever want to throw some financial support my way, you can always use Super Chat, Super Thanks, or PayPal. It's always very much appreciated. Helps keep the channel going. But I think one of the biggest and best things you can do is pick up one of the softest shirts in the CAD game, the new TooTallToby black t-shirts over at TooTallToby.com/merch. All right, let's get into our first answer here. I saw a couple of people coming in with their answers. Let's see what we got here for this first challenge. The odd wrench. We had Rich K come in with the very first answer. Nice job, Rich. 1361 grams. Ali coming in 1358. Rich K revising 1358. And we got, looks like we got a couple other people out there who maybe are still working on this one. I'll tell you what I'm going to do, guys, just for fun here. I'm going to give everybody just a little bit more time. Rob N just came in with an answer. Nice job, Rob N. Very nice. Airwick is here, guys. Airwick is here. Welcome, Airwick. All right, I think what I'm going to do is I'm going to keep this answer hidden for now. And let me just do a little bit of on-the-fly PowerPoint adjustment, and we'll save this one for the end. That's what we're going to do. That way, make it a little bit of a surprise. So we'll do another live solve, and then we'll show the answer to that one, and we'll show we'll show the answer to the other challenge as well. I'm sorry, not another live solve. We'll do another. Well, we're gonna do both actually. We're gonna do the live solve, and we're gonna do another challenge for the chat. So here we go. This is our second challenge. So I'm going to save that answer. I saw everybody's answers coming in. Rob N, saw your answer, 1358. Nicely done. I know there's a couple other people out there that maybe are still working on the first one. So that's fine. You guys keep on working on that first one. But in the meantime, I'm going to challenge you guys for the second model. Unfortunately, well, actually, I'll say it at the end. Okay, so here we go. The second model challenge will go live in 3, 2, 1, go. What is the mass of this part in XXXX grams? This is a 6 millimeter thick sheet metal part. Getting a little on the thicker side. The default bend radius for this is 6 millimeters. So the inside bend radius all around this model is 6 millimeters. The wall thickness all around this model is 6 millimeters. This part is MMGS. The material is 1060 alloy. I know that it's not common that you would bend aluminum like this. I made the first part out of plain carbon, and I didn't want to give you guys two models that are made out of the same material. So I made this one out of a different material, but I know there's going to be some sheet metal people out there that are like, you would never do that. So I know. I got it. This model you can see in the upper left, the tabs that bend up almost touch. There's a 0.1 millimeter gap. So those tabs almost touch that top surface of the model. So what is the mass of this part? Whoops, I forgot to go to full screen. There you go. There's a full screen version. Sorry about that, guys. Full screen version, maybe that'll be a little easier to copy. And here we go, all day. Coming in the chat. I knew somebody was going to come after me. He says, 6 millimeter aluminum will crack on those bends. Yes, I knew it. I knew something was going to happen. Somebody was going to call me out. Yeah, I had a feeling when I was making this drawing. I said to myself, you know what? This probably is really not the appropriate material, but I didn't want to give the crew two models with the same material, and I had already finished the drawing and everything and output it and loaded it up in the PowerPoint. And, you know, sometimes I actually will go through in those spots and just start over. But for tonight, I decided to let it roll, you know, just got to let it roll. So if you, oh, I know it, bro. Everyone is enjoying what you do. I know it. If you are enjoying what we're doing here and you have a free hand, be sure to smash that like button. We know that, all day we are all good, bro. Thank you. But make sure you smash that like button because it really helps the algorithm, helps me get found by other people. I'm on the next model. I'm not submitting the first. Okay, thanks for waiting though. All right, no problem, Brian. Yeah, just wanted to make sure you had a chance to try that one. This is a fun one. Everybody always likes a good sheet metal challenge. And you know, it's a little tricky for me to make these sheet metal challenges because different CAD systems solve a little differently. So I basically always try to make sure that like that the second detail, the detail is more centered on the print. You know, that's really clearly calling out what the gap needs to be, the relief gap. A lot of times your CAD software will automate that process, but I made sure that I made it explicit so you can see exactly what that relief gap needs to be. And that should be enough information for everybody to create this thing. There should be enough information in here. So good luck, and the show goes on. Man, I'm so enjoying this time slot. Gotta say, thank you guys. Thank you. Oh yeah, we do have the same shirt. That's awesome, man. It's great watching 3D CAD live streams with your kids. Nothing more exciting. So just some stuff that's going on in my world right now. I just want to remind you guys, last month we did do a 17-part live stream on how to build a bass guitar, start to finish. There's actually an even better model that has all the strings and everything on it, but we got start to finish. We did the whole thing. It really came out good. I'm very happy with how this thing came out, and I encourage you to check that out. We did everything with this. We did the let me see if I can queue up another picture of this thing without doxing myself, hopefully. So we did some really good work on this thing. I'm really happy with how this came out. We did all the electronics on the inside, which look very cool. All the electronics there on the inside. We did a tuner that actually spins, that has all the appropriate gear mates in it. Here's a picture of that tuner with all the gear mates in it. That came out great. And we did, like I said before, we did the strings. We got all the strings in there. Where's the one that I made with the strings? It's gone. Oh well. Must have that in a different directory for some reason. It's weird. Oh, here it is. Boom. Look at that. Look at that bad boy. So yeah, we did it. And we did it across 17 different live streams, and it's basically like 30 hours of free training. If you ever wanted to know how to build a guitar or how to build a bass guitar, you know, the main things that catch people are like, what do you do about the contouring around the body? How do you blend the neck into the neck cavity pocket? And how do you blend the neck into the headstock up top? Those are like the three big things. And then maybe like, how do you do the strings? That's probably the fourth thing that everybody always wants to know about. So be sure to check that out. It is a wonderful series of free training for anybody who's in the world of SolidWorks. If you're using different CAD, that's probably a lot to ask to sit through 30 hours of training on a different CAD system, but who knows, maybe you'll be able to extract something from there. I also have my calendar up. This is the calendar from January, but we do have the calendar up for February. So some of the things I already talked to you about, the Valentine's Day tips and tricks, the Model Monday Live, the sketching tips and tricks. The thing that's cool is that if you click on this calendar appointment and then you scroll down to the bottom, you can add it to your calendar. So add it to Google Calendar, add it to iCal or Outlook. And that way you'll just have the reminder in your phone. If you share a calendar with other people, they'll know that you're going to be tied up during that time. Airwick already coming in with an answer. Speedy, I like it. And Eric, I'm just going to repeat this. I know I said this to the rest of the guys on the stream earlier, but, you know, I messaged you and Ali earlier, and I said, hey, you know, I have to non-verify your videos because that accidental Ivan exploit. And Ali was like, okay, no problem. Here you go. Like 5 minutes later, he wrote back, and he's like, I got a new submission in there. So I haven't watched his new submission yet, but the link to the video is in the YouTube video comments. So he's just right away. He's like, oh yeah, no problem. I'll just do another one in less than 4 minutes. No problem. Just blast through. Yeah, it was great having you in there on some of those, Richard. Thank you so much for joining me on some of those. It's always good having some homies here in the lives. I also do offer training. I've done a lot of training over my career. I've taught over 200 professional 3D CAD classes, mainly in SolidWorks. And I've taught almost every topic. I'm fully certified. So if you guys ever want to get some training, we can put together something custom. We can do something for your company. I can work with your company. You know, I have my own company. It's part of the services that we offer. So if you have a company and I have a company, we should get our companies together, do some training. I think it'd be awesome. All day, thank you so much for the super chat. I very much appreciate it. It does go a long way, and I very much appreciate it. Thank you. It's awesome, man. And yeah, so any training you guys need, even if it's like something custom, we can do like some CSWP certification training, get you and your team all up to date, all certified. So just let me know what you need, and I can work with your purchasing department, and we can get all the invoicing done and make it happen. On any of the standard classes or even maybe a custom class, whatever it is you need. All right, let's do one more live solve while you guys are working through that. Challenge. Taranjot comes in with his answer for the first one. Very nicely done. I like it. You got to keep going, man. Never stop. Never give up. I like it. Nicely done. All right, let's do one more live solve here. I think this will be good. This will be a good, this one's going to be a good model, I think. So welcome to our live solve here. This is for one of the practice models that I posted a couple of weeks ago. This one is the egg cover cap. And the egg cover cap is a really cool drawing that we put up here. It's got a lot of interesting stuff happening. One of those things is this extra dimension that really shouldn't be here. That was from when I made a mistake the other time, whenever it was. Let me get that diameter off of there. All right, here we go. Start again. Take two. So welcome to this SolidWorks tutorial, this live solve of the egg cover cap. This was a drawing that I posted a couple of weeks ago, and I wanted to go through now and show you guys kind of how a certified SolidWorks expert might think through this challenge. So there's a lot of information on this drawing, and it can be a little intimidating, I know. But I think that the main thing that you want to recognize here is that this is a model that is being revolved. And the way that we can tell that this is being revolved is primarily from the centerline symmetry here. And the centerline symmetry down here, which I know are the same centerline symmetries, and this arc here that's running through the bottom. So we kind of know that all this information is coming from the same kind of centerline section of the model, and that helps us understand how this thing has to be revolved. It really sets us up to understand that the first profile in this model is going to be probably this profile here. You know, we've got this radius 160 coming up, and then there's this smaller radius that we don't really know what that smaller radius is, but we do know that it exists right here, you know, right at this point. That's definitely going to help us understand that this thing needs to be revolved. So what we need to do now is we need to attempt to work through this model based on understanding that this is our first profile. So let's get into our CAD system. In this case, I'm using SOLIDWORKS to go through this, but if you're using a different CAD system, I think you can still take away some pointers from this process. We're going to start a new part. We're going to take a look at the title block. The title block says that the units are MMGS, so we want to make sure that we change our units. You can do that down at the bottom in SOLIDWORKS, or you might have to go into your options somewhere and change your units to millimeters. And the material here is ABS, and so I'm going to pick that from my materials favorites, save some time by having that material preloaded in my favorites, so I can just pick it right from that menu. And then I'm going to go to the front plane, begin a sketch, and I'm going to create the basic geometry for this revolved shape. And so that basic geometry is going to be maybe a horizontal line here. And then I'll come back and I'll touch the end point of that horizontal line. And now, instead of coming off with an arc tangent like so, I'm going to come off with an arc tangent down in this direction. And I don't know what that radius is, so I'm just going to drop that arc like so. And then I'm going to create another arc here that comes down like this with a radius of 160. So there we go. That gives us that radius of 160. And then I'm going to create a vertical line here. And, you know, we could hook those points together just by picking this point, hold control, pick this point, let go of control, and use the merge points command. You could also trim those lines. Either one of those might be a good solution, but I'm just going to merge those points together. And then I am going to take a look at this view here. This is where things get a little bit tricky, kind of have to infer what's going on. But I'm going to notice here in this view, I've got this radius 160, and I've got this 85 here coming off from the center. Well, we kind of have to assume that that's the same radius all the way through, that this, you know, this radius here is just like a continuous arc all the way through. And you can infer that essentially from this view here, not having tangent edges on it. You can kind of infer that it's one smooth radius all the way through. And so based on that information, I sort of know where this radius 160 needs to be in my revolved view. In other words, this view, you know, basically this profile that I'm creating here is going to be the same if I'm looking at it from the front or if I'm looking at it from the side. And so that means that I can take that 85 and apply it here, you know, looking at this from the front as well. And so now the only dimension that I really need, if I, you know, in lieu of that radius, is the overall length of this part. And I can see from the one view that that overall length is 125. So I make that 125. That gives me a nice black sketch, nice and fully defined. That's what your first sketch should look like for this egg cover cap model. And so we can then take that geometry and we can say features, revolve. We can pick this line here for our axis of revolution. We can say we want that to be 180, and we can say that we want that to be mid-plane. And there we go. That looks pretty good. Pretty good start to this thing. Next thing we need to do is we need to hollow this thing out so we can start creating the interior geometry. And we're going to do this with a shell. Now, when we go to shell this geometry, it's probably tempting to leave this face here as part of the shell, but really I think you want to get rid of both of them. And the reason for that is because this face here, it doesn't really go all the way down to the bottom, and it's going to be really tricky to cut just the top part there, and, you know, maintain this wall thickness over here, the integrity of this wall, which would be kind of up in this region here. That's going to be really tricky to cut if we've got that wall kind of going all the way up and around. So instead of giving yourself that additional challenge, just get rid of that wall as well. So in other words, when we go into the shell command here, the typical wall thickness is 6. So let's just get rid of both of these walls here with a wall thickness of 6. And then, you know, we could go back in here, we could pick this face, select face, begin to sketch, orient our view, and we could maybe take this edge here and do a convert entities, and then just sketch a line that comes across the top here like so, and we could trim both of those. So just do a quick trim command here to trim those off, and then we could put in that dimension, which is, in this case, it's actually coming from a weird spot. It's coming from that boss that's sticking up, and that boss is sticking up 15, and then this is coming down 45. So it's really 30 from the top here. I might go back in at the end and redefine that so that it's actually, you know, matching the design intent from the customer. But I'm going to leave it like that for now. Okay, that's good. I'm happy with that. Probably the next thing that I would do would be to create the circular boss that's sticking up out of the top of this thing. So this circular boss here that's sticking up out of the top of this thing. So I can see that that is going to be sketched on a plane that is 15 millimeters up, or at least, you know, the extrusion is going to end 15 millimeters up. I think probably the easiest way to do that is just to make a new plane. So I'm going to pick this face here, and once I pick that face, I'm going to go into my reference geometry command, reference geometry plane. But a lot of times I get to that by just pressing the S key. So this is the out-of-the-box SOLIDWORKS S key menu, reference geometry plane. And then I'll type in 15, enter, enter. So learning how those workflows go, enter, enter, on certain commands can save you a lot of time too. If you're already over there on the 10 key, you may as well just, you know, start typing. All right, so this is going to be at a distance of, at a radius of, or a diameter of 30. It's going to be horizontal to the origin here because it's on centerline symmetry, and then it's going to be at a distance from this edge of the model of 25 millimeters. And since that's already up there, I can S key extrude, so S key, and then I can just press extrude. Remember, if you're working in the S key and you don't have the extrude command, you can go into features here, so customize features, and then you can add the extrude command right there into your S key when you're in sketch mode. Anytime there's a command that you want that's not there, you know, you press S on your keyboard, your right mouse button, you choose customize, you can add whatever you like there. So S key extrude, and then I'm going to double click this face down here because when you're in SOLIDWORKS and you double click a face, that's the shortcut for up to surface. And then I'm going to right mouse button. So in real time, you know, when you're blasting through this thing, if I do a Control Z here, what you can do is S key extrude, double click, right click. Boom. Move on with your design. Nice and speedy. Now, I mentioned before that I might take this boss extrude, this wall here, and redefine it correctly. So the way that I would do that is I would drag this down in the tree, drag it below that plane, drag it down a little further. Let's see, it doesn't like that. Why doesn't it like that? Let's go. Edit this sketch here and see if we can't figure out why it doesn't like that. Is it because of that convert entities? Interesting. Let me delete that. Oh, that's interesting. It almost considered that other boss part of that feature. That's really wild. I don't know why it would think that. I didn't. Oh, of course. That dimension from the end of the model came from there. Yeah, okay. So it was this 25 dimension here came from that edge. So let me just define that to the origin so I don't get a feature creation error. There we go. Nice job, Richard. Odd wrench coming in with the odd wrench. I like it. Ali coming in with the sheet metal one as well. Very nice. All right, so now I can drag this feature down below. And then the cool thing in SOLIDWORKS, and I think there's probably a lot of other CAD packages that do this too. When you want to reassign a dimension, a lot of times you can click on the dimension and then grab the grip and just drag the grip up to the new geometry. Excuse me, up to the new geometry. So if I just drag that grip up, let's see, can I assign it to here? All right, let me hide this plane. Let's see if I can drag it onto this edge here. Nah, it doesn't want to let me do it because it wants it to be to a point. Bet that's why. Oh, there we go. Okay, got it. So now that's going 45, and that's the dimension that's on the print itself. So it's always good to know that you can just kind of drag and drop to reorient that kind of stuff right onto the print itself. So now let's keep moving on with this design. And the next thing that we're going to create is going to be the rib that's defined in this view here. So you can see that this rib is coming over. It's starting out 5 millimeters down. So this 5 millimeters here from that circular boss down to here. It comes over 30 millimeters kind of straight. And then I think that's what's showing there, right? Yeah, 30 millimeters to the start of the rib, or the start of the 190. So it comes over 30, and then it just angles down with that radius 190. So in this situation, what we could do is we could go to the front plane, begin a sketch, orient our view, and then we could create our geometry that comes over here. Actually, right from the center of this thing would probably make the most sense. So right from here, come over 30, enter, come back, touch the endpoint, and then come off with a radius of 190, enter, and then just kind of bring that all the way over like so. And now the only thing we have to define really is the distance to that rib, and then maybe we could do a view temporary axes and then hook this onto that temporary axis. So there we go, nice fully defined sketch. Now it's true we could define this more as well, but the reason I'm kind of leaving this in the material like so is because I'm going to end up using a rib command. Now I'm just curious here. Let's see what happens if we leave this out like so and we go features rib, and we say this rib is going to have a wall thickness of 4, and then we hit the green check mark. Yeah, see, this is what I was expecting. It starts out as an arc, and then it becomes just a straight flat rib for the extension of that arc. So I wonder if there's an option in the rib to control that. Yeah, see, there's not an option in the rib to control it. I know that when you do something like a surface extrude command, you have more control over that. But in this case, we don't really have that option. So we need to make sure that when we create that rib sketch that we're extending it as far as possible. Ideally, we'd want to pick up some kind of a relationship here. So maybe what we could do is draw a center line that comes down and merges to this point, a vertical center line. And then we could take this point and hold control and pick this arc here and make that pierce. And that should give us a result that is consistent, even if the length of the eggshell cover changes. So I like that. I think that's going to be a good solution there. Let's exit that sketch, take a look at our rib. Oh yeah, that's looking good. And then we've got one final rib here, which is also 30 over. So I might take the right plane, hold control, and drag the right plane over here until I get to this point, which is that same 30 millimeters, and just drop it right on there. Or I might do, if I really wanted to do this correctly per the design intent, what I might do is, let's see here, we'll do view this sketch here, single click the right plane, hold control and drag, single click this point. So now I've got a plane that's exactly at the center of that boss. Then hold control and drag that plane, let go, and then type in the distance 30, enter, enter. And now I have a plane over here that has a driving dimension of 30 relative to this plane, which is going right through the center of that boss. This all depends on, how well you know the customer and how much how you can anticipate changes to the model downstream. How important it is to do that extra plane there. But if you know the customer and you know the product line, there certainly could be justification to do that. So it's good to know how to do it. So now this is going to be another rib. It's going to be very similar to that first rib. In fact, it's going to start out at that same height. So it's going to start out right here. It's going to come over with a flat of 50. And then it's going to come down here like so. That's going to come down with a radius of 60. So this distance is going to be from the origin to this point, or the middle of the model to this point at 25 to give us that 50 flat. And then we can do the same trick we did before. We can make a vertical line here and then say that we want that vertical line endpoint to be pierced to this top edge of the model. And that should leave us with just a little bit of the rib sketch sticking into the model as it passes through a curve in 3D space. So we go features, rib, and that rib is going to be this time offset to one side. So offset that rib there to one side, and that's going to be at 4 as well, I believe. Did I not add a dimension to that one? Missed a dimension on this thing, huh? That's not good. Make that 4 as well. and then we are going to hit the green check mark. See here, existing rib does not intersect the model. Okay, the direction of the material is incorrect. So I click on that little arrow there, hit the green check mark. There we go. And now it's just a matter of taking that rib, hold control, pick the centered plane, go to mirror to mirror that rib. And then we'll finish off here by doing a hole wizard hole for the counter bore that is... Oh, actually, this is kind of a weird one too. This is a counter bore, but it's counter bored from the bottom. So you can see here the counter bore comes down and then comes out and then comes down. So in a spot like this, I might consider just doing it as a cut revolve. There's a few different ways we could do this one, but maybe if you're just getting started in 3D CAD, following this as a tutorial, it might be good to know how to do this as a cut revolve. So I would wake up the center here, come across, come down, come out, come down, come over, come up. Finish that off. I would say, you know, I probably want a center line here because that'll let me create these nice doubled dimensions. So when I click a dimension to that center line and come across, that gives me that nice doubled dimension. That's going to be at a diameter of... Let's see here, where is that hole called out? Here we go, 12 for the through. And then I can just single click on this line down here and it automatically gives me the doubled as a subsequent dimension. So I'll make that 18. And then this is going to have a depth here of 75 from the top to this point here. And then for this dimension down here at the very bottom, you know, certainly we could line it up here. A lot of times what I'll do is I'll just put kind of like a do nothing dimension on here. Like I'll make this 100 and then I'll right mouse button on that and I'll say mark for drawing is unchecked. And then I would say this is do nothing. And what that mark for drawing unchecked does is it turns it purple. And when I go to make a drawing and import my dimensions, it doesn't automatically bring in that dimension. It knows to ignore that dimension in the drawing. So features revolve cut. There we go. Hit the green check mark. Okay. And we do what's called the final spin. We spin this thing around. We give it one final look over. It all looks pretty good. And so now we go to our evaluate mass properties and 251.0 for my mass on this part. Let's see if we got it right. Let's see here. Oh yeah, 251 plus or minus 1 gram. We did it. We got it right. So if you like these kinds of challenges, on my YouTube channel, there are practice models playlists. I think there's like 40 videos on there now. I'm going to keep them coming. There's going to be a lot more that come in there, and I'm going to try to pair each practice video with one of these tutorials. So be sure to check out these videos, and I hope you enjoyed that tutorial. If you did, be sure to like, be sure to subscribe, and be sure to come back for more. And so with that, let's get into it here, our final answers of the night. We've got our answer to challenge number 1. If you guys remember, challenge number 1 was the odd wrench. So we had a number of people coming in here and answering this. I think, let's see here. What do we get for some of these answers? We got Rich K coming in 1361, revising to 1358. Rich K sticking it, or Ali coming in 1358. Rich K revising to 1358. We got, let's see here, Rob N coming in 1358. Nicely done, Rob. We got, let's see here. We got TJ coming in 1362. Nice job, TJ. And we got Richard Hill coming in 1358. Very nice, very nice. So let's see what the answer was. 1358 plus or minus 1 gram. Very nicely done. And I think that one goes to Ali, who got the first correct answer. Just barely edged out Rich K, who got in there with the first answer. But Ali got in there 1358, which was the correct answer. Very nicely done, Ali. Very nicely done. Let's see here. Hold on. I can't see my chat. Move this down. Move this up. Okay, cool. Very, very nicely done. And then for our second model, our sheet metal challenge, GG to Ali, by the way, for that first one. So for our sheet metal challenge, let's see what we got here. We got Airwick coming in 543. Airwick revising to 503, and then 511. Ali coming in 526. Let's see here. Ali coming in 511. Rich K coming in 511. This is interesting. I think I must have had a typo here because I thought this was out to 4 places for this one. 6mm wall thickness. 1060 alloy. Hope I didn't make it out of plain carbon or something. Messed myself up. Let's see here. Brian coming in 514. Nicely done, Brian. And what answer do I have on here? 1478. That can't be right. Hold on. We got to take this one to the review. Let's see what we got here in the review. We're going to the review. It is plain carbon. Dope. There we go. We're going to the review. And 511.6. So we call that one 512, 511, 513, 511.6. So 512, 511, 513 are all correct answers. Let's make an adjustment here, guys. Adjustment on the fly. Brian, I know this is your first night. I promise you, it's usually not quite this all over the place. Man, you could tell I was bouncing in between the plain carbon and the the plain carbon and the 1060 aluminum. All right, here we go. The correct answer is 512 plus or minus 1 gram. Very nicely done to everyone in the chat. Let's see here. Airwick came in with 643. Then we got Airwick coming in 543. Airwick 503. Airwick final answer 511.6. Ali coming in 526. Ali revising 511.6. Rich K coming in 511.8. Very nicely done. Brian Jackson 514.9. Very, very close. Let's see here. And Airwick 1478. That must be what it was in plain carbon. All right. I'm glad we got that one figured out. 512 is the correct answer, or 501.6 really is the correct answer. Very nicely done to everyone in the chat tonight. You guys did awesome. Glad you're having a good time, Brian. Thank you for that. Tay Fun, what's up? Welcome, welcome. Thanks for joining us tonight. Work time here in Australia. Another Australian. 2 Australians and a New Zealand. Welcome, welcome. Congrats to all of our winners. Looks like our winner from that round is going to be Airwick coming in 511.6. Very nicely done. Our winner from the first round was Ali. Very nicely done. GG to Ali. GG to Airwick. Very nicely done to everyone. GG to everyone, really. Time to get some sleep. It's 3:18. Ali, thank you so much for staying with us tonight and joining us. Thank you all so much to everyone in the chat. Be sure to check out SolidBox, the professional, no IT required computer solution for all your computing needs for PowerCAD users. Be sure to check out the bass guitar series, the live streams. That was a lot of fun. We got a lot of cool work done on those. And of course, be sure to remember that November 11th, 2023 is going to be the CAD vs. CAD tournament finals. That'll be that Saturday morning. We'll still give you the whole rest of the day for Veterans Day. But be sure to join us on that day. Thank you so much to the amazing chat out there. You guys are all the best. Thanks for joining me throughout this live stream. Remember, let's see here. We are going to be doing a new start time, 7 p.m. And our next show is going to be on, not next week, the 20th, but on the 27th. We got the Valentine's Day live stream going out tomorrow morning. Some really cool tips there for all the SolidWorks users. And then at the end of the month, the last day of the month, the 28th, we're going to do the Toby's Tips and Tricks 2023 live stream. Thank you guys so much. Have a great rest of the night. And I will see you all in the next one. Bye, everybody.